Hello, my name is Amir Jahangiri. I'm a PhD research student in the field of brain-computer interfaces at the University of Essex. My research topic is investigating the possibility of using language in brain-computer interfaces. In the past few decades, there have been a number of brain activities that have been used to identify a user's conscious will. Some of these are voluntary, such as imagined movement or motor imagery, and some are automatic brain responses to outside stimuli. However, these approaches present certain problems. For instance, when you imagine moving a certain limb, if you deviate from the initial trained movement, even by a slight amount, the computer has difficulty in classifying your imagined movement. I've proposed that you can use covert speech as a target mental activity for brain-computer interfaces. So, for instance, you imagine articulating the command left or right, and in theory the computer will be able to recognize this mental speech and act accordingly. My research has shown that firstly, it is possible to use language as the target mental activity. Also, the results I have found suggest that higher mental functions such as speech and cognition occur in higher frequency ranges compared to planning for movement. In the past decades, in the past few years, many researchers have completely neglected the higher frequency range, the higher gamma band, which is from 75 upwards to 175, 200 hertz. The trade-off would be a very extensive computational requirement for training the computer to recognize these signals. However, after this initial training period, the system performs rather well with a very acceptable degree of accuracy. The main benefit of using covert speech or language as the mental task is, in everyday life we continuously have an internal dialogue going on. Whenever we speak, whenever we think, we're using language, we're using covert speech. So this type of activity is very intuitive. So when we speak of a word in our mind, we speak that the same way because we've done it hundreds of times, thousands of times throughout our life. So the possibility of deviating from the activity that we present the computer for its training period is very low. I hope that this type of brain-computer interface will become the dominant type of BCI in the future. And as our computational power increases, and as we are able to implement better sensors for acquiring the data from the brain, the performance and accuracy of our brain-computer interfaces are going to dramatically increase. However, there is a bottleneck which doesn't lie in our ability to analyze the data. It doesn't lie in the ability to transfer the data. The sensors are non-invasive, and from the surface of the brain, as these signals pass through the bone and the soft tissue, they diverge. So it would be as listening to a conversation but from your neighbor's house. And as you can imagine, we lose quite a lot of signal, or in engineering terms, our signal to noise ratio dramatically drops. So the future will perhaps lie in implants. However, these present many technical and ethical problems, or rather, let's say, challenges that will definitely have to be solved slowly but surely. I'm very excited about the results that we have found. They are very promising, and I hope to see this research project come to fruition. Thank you very much.